So thanks all for attending today's session. Thanks so much to the organizers for the opportunity to invite you. I wish I were in Stockholm, as probably most of us would be. Stockholm is so beautiful, I think, this time of the year, but hey, there'll be opportunities in the future. So today I'm going to talk a little bit about learning analytics in terms of basically what brings AI. We all talk about AI lately. I somehow felt that even when we started the field of learning analytics, that learning analytics is tightly connected to AI. But I think it took us basically several years to basically start seeing also, I think, AI as a kind of a hype that many people will start also talking about learning analytics in that opportunity. So I'm going to basically kind of review some of the potential opportunities and challenges that we as the field are experiencing, and how we can potentially tackle some of these challenges and what are the promising opportunities that we can see as we are going forward. Well, I mean, as most of the people who are in today's session, and I'm sure other keynotes already talked about that through different also workshops that you attended, that, we have lots of encouraging results, lots of interest, especially many of us could even see even bigger interest in learning analytics when we were forced last year to transition to lots of online education. And that process, we also want to understand what our learners are doing in that process. But then as part of that kind of process, we kind of start to see what kind of data our institutions have, where we can get this type of data, or about students in schools, what kind of systems are even used, can we understand whether they are engaging at all, and then consequently how we can assist them. So there's lots of interest, there's lots of encouraging results in terms of predictive modeling, understanding of students, learning strategies, lots of basically potential as well demonstrated in terms of personalized feedback, as well as lots of potential that is associated to tackle some of the issues of privacy and ethics, far from being solved or ideal. But I think, as probably many of you would agree as well, that many issues of ethics and privacy cannot really be solved completely. We can just find the kind of conventions that we agree upon and that may work in certain circumstances. Obviously, lots of us are talking lately about artificial intelligence, but in a new way, artificial intelligence. When I was a young PhD student about 20 years ago, artificial intelligence wasn't just about deep learning and machine learning. It was also about lots of logic-based reasoning, etc. But in my talk, when I'm talking about artificial intelligence, I'm going to be following this kind of more conventional recent trend, how we are talking about learning analytics and primarily focusing on the opportunities to make use of big data with the algorithms that are coming from data science, machine learning, and also particularly deep learning, if it's possible to do that. As much as we can see lots of that potential, and we can leverage huge potentials that are related to the opportunities that are coming from the use of big data, the question still is, how do we harness this power of artificial intelligence learning analytics? There are issues that are related to, for example, how we apply some of these algorithms. What are the relevant data that we want to think about? What is basically a good way to present back these results to the users, or how we are dealing with some of these biases? So those are some of the really kind of challenges that I'd like to engage into conversation today. It's part of my talk. And I hope that we can basically think about some of the issues as well together. I'm going to frame my conversation today around three critical components as a part of a model that with a group of other colleagues we proposed some time ago. And that basically kind of talks about how institutions and school systems and broader education systems think about adoption of learning analytics. So thinking in terms of what are the data sources they can leverage, how they can source these data, and then how they can then use in different types of models that are coming from machine learning, and then consequently how we can see some form of transformation that is happening across our institutions. So I'm going to dive now in each of these three elements and think about what are the critical issues. Well, I'm going to start first from the first issue, and that one is that while we often say that we have to deal with huge potential data, and some of this data indeed can give us some good broader trends, often what we are experiencing, especially what is related to the use of data from different learning management systems, is that the quality of the data is not ideal. Why? Because the data is often very sparse. often that data really is not that kind of extensive that gives you enough, if you wish, data points or a signal based on which you can determine what our students are dealing and how they are doing with certain things. So no matter how strong algorithms we may use and try to torture this poor and sparse data, we are not going to be able to deliver much better than if we use some of the kind of very common statistical type of algorithms, some of the more conventional types of statistics. So in principle, like I remember when we were opening the first Learning Analytics Summer Institute at Stanford 2013, I was talking about this phenomenon, problem of garbage in and garbage out. And even if you apply powerful algorithms, you can just get garbage on steroids as the output. So we really need to think about this really fundamental challenge. So data and learning analytics is not going to be solved, and the problems of data quality just with the application of artificial intelligence. So what we need to do is we need to go back to the basics and think about how we can improve that quality. And quality really of data improves with good quality learning designs that makes certain tasks and activities for our learners inside of these learning environments from where we want to collect some of our data. And to me, this is really critical. We need to create these opportunities for learners to demonstrate whatever we try to measure there, whether we are interested in engagement, whether we are interested in their quality of self-regulated learning, into quality of their, for example, collaboration and so on. So if we don't create these tasks for the learners, they are not going to produce the type of data that we are interested in, as simple as that. The other critical thing, and I think very promising thing to do, is to think about how we can purposefully embed small little tiny features for data collection straight at the source where the action happens. And that can enhance the quality of the data. I'm going to talk about a very simple example. That embedding of the features cannot come at the cost of the learners by saying, oh, just give us more and more and more data. Learners have to get something back in return if they want to basically provide us with some additional data. And that basically return, I call this kind of a principled quid pro quo. So this is a small little application that we developed some time ago. And in that process, we were thinking is how we can, inside of any activity learners are taking in a conventional LMS, provide us a couple of data points with a single click. And that single click, basically, as you can see on this screen, is provided or offered through a 2D canvas. And this 2D canvas has two axes. One axis represents a cognitive load, and the other one, in our case, was representing self-efficacy. So with a single point, so for example, when students would find something that was challenging for them, and also that, for example, decreased their confidence they can complete the entire course they were working towards, that would be basically in this kind of lower left quadrant of the screen and the activity. But what is really interesting with this process is that not only do learners provide us with this, two data points for any of these activities, but also we are for them directly using that as a bookmark. So they can use that later on for planning of their activities. They can find easily activities that they found that were very challenging, and also they were reducing their confidence, and vice versa. Some of them they found really encouraging and so on. So that's one point for the learners. So for example, depending where something was in their quadrant would be classified in another page that was basically providing this type of information for learners to use. But what is even more important for us, we as the educators can make use of that data point or those data points for back and, for example, provide personalized feedback to the learners. Or we can even just monitor what was happening this week with the activities our students were taking. And then next week when students come, you can directly address some of these critical activities. And so we call this basically principle quid pro quo. And this is what we call is also traced self-report data collection. Obviously, one other natural point for our future development, and where I see really that artificial intelligence in particular can offer us a lot, is if we start really improving the quality of our data through a range of multimodal and multi-channel data. So these different channels are, for example, opportunities to use eye tracking or opportunities to use even we don't use much keystrokes, we don't use much mouse movements. That's really very promising. And we really need to think about what is the effective way to incorporate this type of data, and especially because these sources of data become far more intensive in terms of the signals. I'm moving my eyes all over the place and all the time when I'm talking to you now, and that can become lots of data points that require very sophisticated types of algorithms. We've seen some excellent work. I noticed Sana Yervela is in this room today. She's doing absolutely terrific work when it comes down to the use of multi-channel and multimodal data. We've been also collaborating with other colleagues as well in terms of understanding an improvement of what we can measure, for example, just with the trace data, conventional log data that we are getting from our files, to the next level that is much more related to the collection of keystrokes and mouse movements, and then what happens when we are incorporating another level that is related to the collection of data like eye tracking. And finally, how we validate. What is the validity of these types of data is really important and useful to think about. The second point, and I think this is the critical point where we need to think about really artificial intelligence. We produce models. We are really trying to understand what is happening inside of our data, and we really need to produce some answers. But it's really important that we start and we get these answers based on our questions rather than just data to tell us something. It is useful to explore your data, but often you may basically, ask the algorithms, all right, here's the answer, yes. But what was the question? Why are you getting that yes? And it's really very important for us that we go back and understand what is really that is driving our decisions with respect to some of these algorithms. So really what we need to do here is to have the emphasis on understanding on the context in which that data was collected. And we need to really think about the importance of learning design that is shaping, as I previously said as well, the behavior and consequently the types of traces that are coming from our data. And secondly, also what we know about learning, teaching, and education. And often that comes from the learning sciences, which is really an essential point for us. So in principle, as much as we like to use our AI algorithms, we need to go to this very kind of basic thing, very obvious, something I've been talking about for many years now. And that is that learning analytics is about learning. And when we say something like that, what we need to bear in mind is, for example, that instructional conditions shape results of learning analytics. So we had this study about 5 years ago now published, in which we demonstrate if we try to lump all our data together in one huge data set and predict, for example, students' risk of failing a course or students' grades, we really don't get so much actionable information in terms of these useful predictors. We just get basically these predictors that are least common denominators. And that's often how many times I logged into the system, but nothing beyond that. And therefore, it's really essential that we start thinking about how we are modeling by integrating the critical components that are shaping our learning. More recently, I had a pleasure to collaborate with an exceptionally talented group of people in which we kind of probed additional thing, the extent to which my personal characteristics as a learner are really explaining the outcomes versus, for example, the course design versus some really super cool features that are emerging from the learning designs. And what we found is that actually these individual features, individual properties, if you wish, of the learners are explaining about 60% or more variance in the outcome when we are trying to kind of generalize that across many different types of courses. While, for example, when we are looking into the kind of some of these interesting variables that are coming and explaining some of our data, like regularity of study and so on, they were explaining usually 3 to 5%. So this really tells us something important, and that is that we really need to focus much more on the modeling of the learner, understanding the ways how learners are learning and trying then consequently cater to those needs. So what is one possible direction? I think a good opportunity is to try to study and understand learning tactics and learning strategies. That is to say, what are those specific patterns of the ways how learners operate on information and how they are approaching their learning when they are in particular learning environments. And in this particular case with tactics, we often mean like very specific, unique operations that are performing, or like a shorter period of time, how they're studying, while with strategies, we really look into the more extended period of time while and how learners are studying. So what we know so far about the potential for learning tactics and learning strategies? One is that they are really predicted or shaped completely by the learning opportunities that are provided in our environments. That is our learning designs, which basically means if we in our designs often lots of different formative quizzes, often some videos, but we really don't scaffold much work on the discussion boards and other types of features, we are really going to see the tactics that are really shaped towards these opportunities that we already envisioned in our designs. But what is really also interesting is that regulation of strategies is far more consistent across different contexts. So for example, we studied that in fully online contexts, blended contexts, and even MOOCs. And what we are also seeing is that often we are finding really good associations with approaches to learning, which is one instrument that is previously studied, and conceptualization, the way how we can promote deep versus surface type of learning. And also even some opportunities to study, understand that learners take their strategies that is associated with personalities as well, which is a well-established way to measure that individual differences in psychology. What we also see is that strategies are very much associated or predictive of academic performance. But in this very specific case, I also have now very clear reason why something is predictive of the outcomes. And consequently, I can try to nudge or promote my learners to improve their learning strategies towards those that are promoting more effective learning. And this is in precise what we actually observed as well, that if we develop particular instructional interventions, like in some of our work, personalized feedback that is catering to these learning tactics and strategies, we can then even see that they are getting positively associated, as we are seeing a good trend that learners actually are engaging into more productive, more effective learning strategies that is part of their process. And what is really interesting is as part of this process as well, and the power of some of these algorithms that we are using, I'm not talking much about algorithms today, but I'm happy to take any questions on that topic, is that we can also start gradually explaining the underlying mechanisms. For example, in a recent study, we demonstrated how some of the processes of self-regulated learning can be now explained that are associated with particular types of learning strategies and tactics, which give us much deeper insights into what we mean about learning and how our learners are regulating their learning activities. And then there's another critical thing. With the use of these learning tactics and strategies and the use of some of these promising algorithms that are emerging from artificial intelligence, we can really see and measure almost effectiveness of particular learning designs, how certain designs are promoting certain types of learning strategies and learning tactics. And consequently, based on these evaluations, we can see the extent to which we can also promote some of the interesting learning opportunities for our learners. What I want to also emphasize is some really interesting work, to return also, by the way, favor to Mohammed as well, and give a plug for his work, is that we really, as we are talking about individual students' differences, models that are coming from something which is called ideographic modeling is really important. That is to say, taking huge amounts of longitudinal data about one individual, where n is equal me, or when is n equal 1, like Phil Winnie has been promoting for the last almost 10 years in learning analytics. This is really how we can start narrowing down what is the level of progression of me as an individual learner, and how we can cater to my own personal learning progression, rather than to think about many of these things at the population level. So we also need to really think with respect to some of these models, is that we often, if we use some of these deep machine learning algorithms, is that they can offer us a fair bit of limited insights into what is actually happening behind the scenes. I mean, like deep learning algorithms can offer us really improved precision if we are, for example, doing certain prediction, and we saw that. But the key challenge for us is to really think about explainability of these algorithms. And what do we mean by explainability in learning analytics when it comes down to these algorithms? How do we get to that point that something is explainable? Is it just machine learning, as some individuals are saying, as Caroline Rosé and others were saying, that that's not sufficient? And in our more recent work, we are suggesting that basically for explainable learning analytics, we really need to think who are our main stakeholders. We also need to think about what are the potential pitfalls that need to be considered as part of the kind of explanations that we need to build. What kind of benefits we also need to promote, whether that's even students' agency or what do we want to kind of promote, what are the values that we need to think about in terms of that explainability. And also we want to think about what is the design of some of these tools that we are trying to offer, and how these algorithms that are offering certain insights are going to tap into some of these tools. And obviously need to think about what are those approaches that are used for presenting explanations, and how some of these things can be really leveraged in terms of the machine learning algorithms that are out there provided. Another really big challenge that I think we only started to recognize, mostly in the kind of conceptual debates in learning analytics, only very, very few works have been done in learning analytics. Probably a good example is George Gardner's and all paper at LAC 2019, the best paper awarded, by the way, where they proposed a really good metric for measurement of the bias in algorithms. And we tried to take upon this a metric to understand basically how that is, for example, applying to the understanding and analysis of online discussions that students have. And I think this is a really important topic. We need to start measuring and acknowledging different types of biases that are associated with particular types of groups that are available. While certain bias may be applicable to male in particular contexts, that might not be the case in some other contexts, depending on the distributions of the learners and the overall populations that are there available. So we really want to kind of understand how that is and what is happening, and more what we are seeing is here that, again, in terms of the measurement of bias, this in a way motto I've been promoting is one size fits all really, again, doesn't apply even when we are measuring bias in education. And I'm gonna try to finish my talk with a discussion about this kind of transformation. And when we are talking about this kind of transformation, we really want to think about how we can create analytics tools for non-statistics experts. So I want to use that tool, but I have no idea about machine learning. I have no idea how these tools are what kind of technologies we are using underneath some of these really fancy analytics that are available. Often we say, well, cool, let's develop dashboards. But we often know that in terms of dashboards, what we learned so far is that can be harmful. And we basically found so far many studies. I think a good example is a randomized controlled trial, which was published which was done at Stanford University and published 2017, which basically found that students who were encouraged to use the dashboards that are comparing them with the class average or giving them some distributions of the history data that previous students were taking particular courses actually had a negative effect on their GPA over the course of years. So in principle, what we really want to kind of think of to avoid is to avoid showing or visualizing what is easy to be done. We really need to move away from these type of notions. And what we really need to think, even when we are talking about artificial intelligence, is to have the human in the loop. So we need to deeply engage our learners, our stakeholders into co-design practices that are part of the process. We also need to be careful about how we are designing some of these products that are out there available. This is a terrific work that was done in the lab led by David Schaefer at the University of Wisconsin-Madison, where they basically were conducting and creating the particular types of dashboards, which were simplified versions of epistemic network analysis of the chats students had when they were discussing within their virtual internships. And so there's a fair bit of artificial intelligence. First of all, these textual data had to be automatically analyzed, categorized according to these categories that you can see in this diagram that is shown in the middle of the screen. And then not only did they do that, but also through the kind of co-design, they also suggested interventions that the teaching team could take and even provide some additional explanation, which is provided in this little corner here. Another really important thing is to think about the empowerment of our users. So the work that was led by Abelardo Pardo here in Australia on ONTAS, which basically allows teaching teams to create personalized feedback that can be scaled and that really can be scaled. So the amount of work, whether you are supporting this type of feedback, is as if you're investing support for 4 or 5 students, but you can reach out to thousands of students. That's really, really very promising work in learning analytics. But as we are going here, we really need to think about how we are measuring the impact of that feedback, and artificial intelligence allows us to do that. Another important thing that we are thinking about that is that we really need to think about what is that level of automation that we can get with the feedback. Is that level of automation is just driven by AI, but also that we need to incorporate content knowledge or pedagogical knowledge. I see also that Mohammed is getting nervous about me. I have 2 more minutes, Mohammed, to say about the topic that we are discussing. And that basically is one critical thing, is that artificial intelligence can be really good for us in this process as an opportunity to develop feedback literacy. And how we are doing that, there's promising really work that has been done and that is related to the kind of understanding of the quality of feedback that we are writing in text. So we can understand the promising properties of that feedback. The other one is basically automation of that kind of feedback that I can automatically generate. And these are some of the really interesting points that we are getting there. One is that basically automatic feedback increases students' performance. And this is the outcome of one of the systematic lit reviews that was recently published. The other one is that there's no evidence that that automatic feedback is easing the instructor's workload. So we need to really pay attention. What are the implications of that kind of automation that we are dealing with? The other one is that there's no evidence that manual feedback is more efficient than automatic feedback, which is really promising. And this is a really good opportunity for us that learners really appreciate that type of feedback. But then when we are really thinking about that feedback, we need to go away from automatic feedback that is kind of just measuring what is the correct answer. But we really need to focus on process of learning. We really want to give guidance how learners can improve their learning. And just to wrap up the talk today, I want to basically just say that, look, I think I hopefully made a little bit of a case that AI offers much potential to advance learning analytics, but AI cannot really come on its own. Learning analytics, and I've been advocating for a long time, is basically where education, design, and artificial intelligence meet. And I think when we are thinking about the use of and future development of learning analytics in the age of AI, we really cannot lose sight about what are the core values that we want to promote and what is the approach we are going to engage our stakeholders to design different types of analytics that can make a difference. Thanks so much for the time